if p squared minus 1 over q equals to 4. A. Express p in terms of q. B. Find p when q equals to 12. Solution. Solution to the A part of the problem. Now we have p squared minus 1 divided by q is equals to 4. I want to make p the subject of the formula. So the first thing to do is to ensure we transfer any expression that is not a function of p from the right to the left or from the left to the right. But here now, we have minus 1 over q. We are going to transfer this to the right hand side. So let's see. P squared will be equal to what? 4. By the time we move this, it will become what? Plus. Because this is minus, it will become plus here. So plus 1 over q. Now, p squared is now equals to 4 plus 1 over q. This is not the final answer because we are asked to express p, not p squared. So for us to remove raised to power 2, what do? You take the square root of both sides. By taking the square root of both sides, we have 4 plus 1 over q. So square root of p squared will become what? P. So p equals to square root of 4 plus 1 divided by q. That is the solution to the first part of the problem. Now the second part, B. For the B part, we are going to use this. We have P equals to square root of 4 plus 1 divided by Q. We are now asked to find the value of P when Q equals to 12. So when Q equals to 12, P will be equals to what? Anywhere we see Q, we replace it as 12. So we have 12 here. So this is like 4 divided by 1. Now, P will be equals to square root of, now what do we have here? The LCM of 1 and 12. Because we're having a fraction now. 4 over 1 is a fraction here. 1 over 12 is a fraction. So for us to simplify this, what is the LCM of the denominators? Since we're having 1 and another number, the product of the two numbers will form the LCM. The LCM of 1 and 12 now is going to be 12. That's 12. Then 12 divided by this 1 will give us what? 12. 12 times 4, we have 48. Plus 12 divided by this 12, 1. 1 times 1, we have 1. Then what are we having? P equals to square root of, what is 48 plus 1? 49. So we have 49 divided by 12. Is there any way we can reduce this? Now, the number that we divide 49 is 7. So 49 is a perfect square, but 12 is not a perfect square. So we have to simplify. This will give us square root of 49 is 7. But for 12, we have square root of 12 like this. We have to simplify this. This is going to be what? 7 divided by square root of what? 4 times 3. We need to bring out a perfect square in 12. The highest perfect square number we can see in 12 is 4. So that is why we are having 4 times 3. 3 is a non-perfect square number. So in this case, we can find the square root of this 4, which is what? 2. We now have this divided by square root of 4 times square root of 3. Now from here, we are now having 7 divided by what? Square root of 4, 2 root 3. Now, square root of 4 is 2. Then 2 times root 3. That will give us what? 2 root 3. Now, we need to remove this root 3 at the denominator because root 3 is an irrational number. So for us to make the denominator to be rational simply means we should turn square root of 3 to a number which is an whole number. And how can we do that? We are going to use this irrational number to multiply both numerator and denominator. And that process is what we call rationalization. So in that case, P will now be what? 7 times root 3 divided by 2 root 3 times root 3. That is, we are using root 3 to multiply both numerator and denominator. So in that case, what are we going to have? 7 times root 3, that is 7 root 3. Then divided by what? 2 into bracket what? What is root 3 times root 3? Root 3 times root 3 is root 9. So that is root 9. Then we have 7 root 3 divided by what? 2 into what is square root of 9? That is 3. So in this case, we have what? 2 times 3, that is 6. So at the denominator, we are having 6. So we now have this as 7 over 6 root 3 as the final value of P. So it means that the value of P when Q equals to 12 is 7 divided by 6 root 3. That is the solution to the problem. Thank you.